Okay, I'm finishing up where I left off yesterday. I'm looping the transformer back into the battery, and I have a stat power inverter hooked to the battery, positive, negative, and all that. It's hooked up, the light's on, 120 volts is coming out through the white cord. 120 volts goes into it. Coming out of it, 16.42 volts DC from the secondaries, the two secondaries in series. This is the primary that's fed the 120 volts from the inverter. So I have 16.4 volts on display, ready to be pumped out from this full wave bridge rectifier that's rectifying the AC coming out of the secondaries. I already have the ground of the full wave bridge rectifier hooked up to the ground of the battery, and as soon as I hook this white wire, which comes directly from the positive of the full wave bridge rectifier, I'll be making the loop of. And right now, I'm looking at what the battery voltage is, and it's 11.99. And that's as it's running this inverter. And the inverter, 120 volts, goes into the transformer. So that's what I got for voltage. And I'm lighting up the light on the inverter. Now, here's what's very interesting. I don't know what it means. It's 16.41 volts I'm going to be charging this battery with, right? But watch. When I complete the loop and hook the positive of the full wave bridge to the positive of the battery, the voltage, the 16.4 is not 16.4 anymore. It goes up to almost 20 volts. There it is, 19.8. Isn't that interesting? While that battery voltage, it has dropped now. 11.93. 19.81 is being fed into the battery, but actually it should only be 16 volts, but for some reason it goes up to 19.8. Now I have an ammeter. Here's what I didn't get to yesterday. I have an ammeter in milliamps DC, and I'm going to hook this white wire here. It's the positive from the full wave bridge rectifier. I'm going to hook that up to the ammeter, and I'll hook so now I'm measuring current going into the battery from the full wave bridge rectifier. See, it's kind of weird. That's all I get from it. Let me turn the light on again. Okay, I hook it up 1, 2, 3. That's all I get. Seems like it's going the wrong direction, doesn't it? So I'm going to switch the leads on the ammeter and measure going the other direction. Now what does it say? Oh. This is weird because it's saying negative, but I just switched the leads. Weird. So let me do that again. Right now I have what's coming out of the full wave bridge rectifier going into the common of the ammeter, and the red is going to be hitting the red here. So I actually am trying to measure the current going out back to the full wave bridge rectifier. The direction should be that. But what's weird is it says negative. No, it doesn't do it. It's telling you these were weird measurements yesterday. There we go. So it's saying negative 377 milliamps. Negative. But I have the meter in backwards, so that's actually positive if you think about it. So let me go back to positive. Okay, now we have the meter hooked up to measure the flow from the full wave bridge rectifier into the positive of the battery. Okay, and I touch it. It says practically nothing. Let's do it again. That's all I get sneaking in there from the full wave bridge. So that's strange. Probably has something to do with the voltage. I don't know. This weird. Let me do that again to show you what I mean. 16 volts coming out of here. Now remember, I'm running an inverter with this at the same time. So when I touch this, you would think it would raise the voltage, but it doesn't. Raise the voltage of the battery. Actually, that's not bad, considering it's running the inverter and the voltage hasn't dropped. And now there's 22.5 volts coming out of that full wave bridge rectifier. Isn't that strange? And now the voltage of the battery, at least, is staying right around 11.99, and there's still 22 coming out, going in. But if I don't connect to the battery, it goes at 16. So, okay, you all see that now. Now yesterday, this is where I was getting quite confused when I was saying I couldn't get readings of current very good, and then my inverter broke. So now let's measure what's coming out of the battery into the inverter in current. Okay, this should be pretty easy to do. Okay, one moment. Okie dokie, so we have 150 milliamps measuring coming out of the battery into the inverter. 150 milliamps DC. Meanwhile, the inverter is being pumped into the transformer, and meanwhile we're getting that 16.4 out. But now let's complete the loop, hook the positive of the full wave bridge rectifier to the positive of the battery, and let's see what this says now over here about how much is coming out of the battery into the inverter. There we go. Okay, I'm hooking this up, and it's still only 150 volts. I mean milliamps coming out of the battery to the inverter, powering the inverter. And you know what? Feels like this wire is getting kind of hot. So the battery voltage is not really dropping, it's about the same, and I'm sucking 150 milliamps out of the battery to power the inverter, and the inverter powers the transformer, and the transformer gets rectified and pumped back into the battery. And again, the anomaly is I have 22.5 volts showing up DC going into the battery. Don't know what to make of all this, but the voltage is pretty steady on the battery, and that's all that it's drawing into the inverter. Now, I had twice that current when I hooked the ammeter up backwards, and then it showed that the current was backwards, so that would negative and a negative equals a positive. So I don't know what to make of that. So any of you have any ideas what's going on, let me know. And did it. Okay, thanks for watching.